there's lots of ideas in this regard around Green New Deal, right? So that's been sort of launched in the UK. Corbyn sort of backed that, and in the United States, you have AOC. You have Bernie Sanders and others who have sort of said, we actually have to really think through. So this is one framing for a kind of green transition through the lens of what we call cosmo-local production. Oh, so this is not, I got to play, right?
Maybe that's.
Is that going to work?
Yes.
Yep. Okay, good. So let's begin with the idea of the use future. Use future is an idea developed by futurist Sohail Inayatullah. And he basically says that a use future is an image we have in our mind of the future, but it's not working anymore. The context has changed. Or it's just a future that we were disgusted with, right? So here are some examples. The Nazi right's idea of racially superior, one race being superior, others being inferior, right? The Übermensch, the Untermensch. That's a used future, right? I think we can all agree on that. We had the Green Revolution, right? That brought agriculture, bountiful agricultural production through high inputs, right? That's actually a used future. It's not viable. We've got soil depletion, we've got the impacts that has on all kinds of ecosystems. The idea of men. So this is interesting. That says, "That's right, sweetheart. Dreams and goals are Satan's way of distracting you from making dinner." Right. So the idea of one gender being superior to another, that's also used future. And you know, lifelong branding, right? Branded for life. Used future. Consumerism, used future. So we can think through. We can even think, you know, like Donald Trump said, we got to bring back coal, right? Bring back those coal jobs. I mean, for God's sakes, right? You know, we might as well bring back the bubonic plague. Right? It's kind of already here. So, what are the used futures of production? When we think of our industrial production systems, massive impacts on ecosystems. We're within ecological, you know, they're not within ecological boundaries. We're way out of ecological boundaries. Huge amount of waste production within a context of diminishing resources and impacts. High carbon transport. Things are transported from one place to another, one part of the world to another. Global supply chains, and it's basically diesel fuel. That's what it is. There is no alternative if you want to get something from Hong Kong to here. Fossil fuel-based energy systems. Now that's changing. California, Germany, little by little, different parts of the world. But still, you want to produce a car in some part of the world. You want to produce, you know, cupcakes or whatever. Predominantly, you're going to end up using fossil fuels right now. Unemployed communities. So there's communities that are stranded on the old system. There's communities here in Australia, in Victoria, in the Latrobe Valley, whose whole livelihoods have been based on mining for coal, right? Job loss through automation. So increasingly, we're going to get companies that are going to automate. 20 years ago, I was in a Toyota factory in Japan, and I couldn't believe I saw robots running around everywhere, taking stuff to different workers. The place was almost empty. That was 20 years ago. And of course, unevenly distributed benefits from profits. And that's a lot of what we're talking about today. So this is a model that Gareth Priday and I use in a lot of our futures work. It's called Three Horizons. It's developed by Andrew Curry and Anthony Hodgson. They're futurists out of the UK. And the basic idea is that you have systems that over time may, not will, may, so this is a question mark, you know, and that connects with that, you know, sort of uncertainty question that you were talking about, Richard. may decrease in its fitness, in its strategic fit with the environment. It might be less prevalent over time. So we have incumbent systems, or systems which are prevalent, and then over time, they may be less and less viable. And may is the sort of optimal word there. There may be alternative systems that may become more viable over time. And so what I want to do here is just kind of use this model to help think through, what does a transition actually mean? What are some of the dynamics within this transition? What are some of the elements within this transition? So this is called Horizon 1. This is what works now, but not in the future. Right? You've got the current system, you have a dominant view, you have the power of incumbency, people protecting their interests. And it can be difficult to imagine alternatives. This is the business as usual, keep the lights running mentality. So in this Horizon 1, this is why the current system doesn't work. It's the problems of the existing logic of production. We have transport costs, impact on ecosystems, excessive waste production, job loss through automation, stranded or lost communities, fossil fuel-based energy systems. And in the same way, we also have this second part, this new technological birthing that we've had over the last 15 years, which combines global open source, peer-to-peer technology, and new advancing high-tech localized technologies. And we can talk about it in different ways, but basically it's open and distributed production. It's the ability to take a design from somewhere and to make it happen locally. So the open source and peer-to-peer movement has transformed the basis of IP and design. What that means is that there are now pools distributed depending on what industry or what sector, where people contribute their knowledge. It can be open source, or it could be at a certain particular cost, but it's transformed the whole idea that IP is going to be held by a company for something. New technologies such as 3D printing, CNC routing, small-scale injection molding, robotics are quickly advancing. Robotics is scaling down and allowing more complex tasks to be done with greater precision. And finally, distributed energy production, storage, and management, or microgrids, mean that energy-intensive production processes will not be dependent on large-scale energy grids. So if we think, I don't know if people have seen that film 2040, but there's a great example in that film where, I don't know exactly where it was, it might have been India or Bangladesh, but it was a whole town that had their whole energy system on a microgrid. They weren't connected to a big grid system. They had their solar on each of the roofs, and these are people that are probably making, less than $2,000 a year in income, but they've managed to build a system like this. So these are the two forces working simultaneously that, in this argument, makes the current logic of production less and less and less viable. One, you have problems with legacy production systems. Massive amounts of waste, over ecological boundaries, stranded communities. On the other hand, you have the potentials of open and distributed production technology. And these are the two things that I think combine and provide a potential for transformation. So we're not just interested in what won't work, but in a different and better system. So Horizon 3 in this model is, it doesn't work now, but it can in the future. It may in the future. And there's many different routes to the future. So, as a futurist, we're not deterministic, right? So very much as you're saying, Richard, there's uncertainty. there's complexity, and you cannot predict the future. There's too many interacting forces. And on top of that, we all have worldviews. We all have ideologies, right? And that's going to shape the nature of what we see. My worldview sees this as a preferable future. Other people would not have that as their preferable future. So this is why it can work in the future, right? Regenerative production within ecological boundaries. That's what we need. We need localized production, minimization of transport, circular economy, distributed microgrid-based renewable energy production, the use of localized automation and robotics, and stranded economic communities find new economic pathways. So ways in which people like coal communities in the Latrobe Valley can say, okay, well, we're not dependent on that old system. There's something new that we can start to do. So this is what I and the Peer-to-Peer Foundation and many others have been exploring. It's basically this model in which you have local scale open source production. So based on open source design, because it's freely shared, it potentiates other people in other localities taking those designs and adapting those designs. So we've got this virtuous cycle that we sort of can think about, right? If we have open designs at the global level, communities can take those and make use of them. If we have open design for malaria, right, for malaria medication, people can take them locally and they can manufacture them. In the localities, as people actually do their application of the design to solve a problem, they can keep that open, and that becomes the use for the next group. Skip that. And then here's some of the other sort of dimensions. I'll just read this out. This is by Michelle Bowens. The idea of pseudo-abundance is based on the mistaken premise of infinite material growth on a finite planet, where natural resources are actually fundamentally limited. Artificial scarcity refers to the strategies that prevent the sharing of technological and scientific progress because of excessively restrictive intellectual property rights. A sensible alternative is to recognize the limits that we can use from the world of nature, of which we are an intrinsic part, and to allow for the sharing of all knowledge that can contribute to living within the limits of this biocapacity. Right? So we've made knowledge scarce, but in the world, in our new digital world, knowledge shouldn't be scarce. The solution should be open for everyone. And we've made resources artificially abundant, right? By subsidizing coal extraction, mineral extraction, a whole number of other ways. So I'm going to go through just a couple of examples of people doing interesting work. So this is FarmHack. They're in northeastern United States. And they basically cultivate a community of farmers that come together to prototype farm tools. And there's a picture of them prototyping. If you go on their website, you'll see hundreds of farm tools. They're predominantly organic farmers. And they don't want to be locked into the restrictive nature of big ag IP. Big ag is incredibly restrictive in IP and doesn't necessarily tailor to their needs. And so and all of their designs are open source. So any farmer in Africa, in Asia, South America can go online, grab their design, and they can begin to use it if they want to. This is L'Atelier Paysans in France, and it does the same thing that FarmHack does, but it's based on a cooperative model. They're a co-op, they get a little bit of funding from the state in that subsidiarity system that France does so well, and they go around in almost like a caravan roadshow from town to town, and they work with farmers to, again, do prototyping. They're predominantly organic farmers. and their needs as organic farmers are different than the big ag farmers. So they need to do it for themselves. But they keep their designs open. That means the next town can use it, the next town can use it, the next town can use it in this virtuous cycle of creating open source resources. This is precious plastic. They basically are designing ways in which we can take the plastic that we create and throw out all the time, every day, and transform it into new things that we need. Here are some of the examples of some of the machines that they have. They're machines for shredding and machines for this and machines for that. It's all open source. They've cultivated a community around the world, a very rich ecosystem of people doing projects using and uploading new systems to the precious plastic database, right? So again, this is open source, but kind of open source and local production in the context of circular economy and the needs of circular economy. This is Open Motors. They're based in Silicon Valley and in China, and they produce an electric car framework. So it's they use open hardware technology. They have some secret sauce bits that you can't access, but what they allow you to do is take their framework and you can import it, and then you can resell it. So you can customize it and resell it. So you can become your own electric car dealer based on their framework. And they also do a thing called mobility as a service. So not just selling the car, but selling what the car can do within a particular context, like an automated bus, right? WikiHouse, I think, started in the UK, but it's spread different parts of the world, and they basically do that. They do that for housing. They have database of design. They have a particular framework around. So WikiHouse want to reduce the amount of things needed to build something, right? The amount of glues, the amount of nails. So they design for a particular type of simplicity. And they've prototyped stuff all over the world. And again, it's in their database, and someone can take it and they can apply it. So someone here in Australia could say, I want to build a wiki house. And all the stuff would be there. And in many cases, this is based on CNC technology. So instead of having to cut it all yourself, you have a CNC machine, you have all of the files, you put it into the CNC machine, and it spits it out. It spits out the parts that you need to put it together. So this is what really is the game changer here. If it was just open design, and you had to do that design by hand every single time, then you're like, okay, well, that's still a little hard. But when you have the robotics technology and the different technology that's localized in production, that's when you start going, oh, okay, this other system might be possible. AbilityMate is in Sydney, and they have been basically prototyping scanners and prosthetic devices for kids with people with disabilities. And they also have this commitment to open source. That's one of the prosthetic devices, and that's Johan, and he's also a Sydney-sider. The SOLS project is one of the most exciting projects. That one's in India, in Maharashtra. Basically, it was developed by the Indian Institute of Technology. There's a lot of people in India, a lot of villagers, who are dependent on kerosene to light their houses at night. It's expensive, it's toxic, it burns fossil fuels. And so the Indian Institute of Technology said, how can we change this? They use open hardware to design and build solar lamps. They developed repair businesses alongside, right? And then they distributed the lamps, said if you need to fix your lamps, you go to these repair places, and the repair places make money from the villagers who need a lamp repaired. So they've, using kind of an anchor institution model, they've bootstrapped a kind of microeconomy of the production of solar lamps, the repair of solar lamps. And they even created a cooperative to produce the solar panels, which is super exciting, which is run by indigenous people in India. Super exciting project. Farmbot is basically, they took a CNC router and they replaced the plywood with a garden bed, right? So it's a pretty simple concept, you know? CNC router, garden bed, Farmbot, right? But it's also open source, so you can buy one, you can modify it, and they have a community. So a lot of these companies, some of them are cooperatives, some of them are associations. Some of them are very VC, you know, venture capital type stuff, right? So it's different models. It's not unitary. It's a big umbrella, you know, but there's a commitment to the open source there. And then I'll just talk really quick about this project and then wrap up. I hope I'm doing okay on time. So, yeah, thank you. So, Cape Town in South Africa was facing a water crisis, like many of the towns in Australia are still facing a water crisis. I don't know after this deluge that we had last month, but they were facing what was called a day zero, right? Day zero is like, you know, can't take a shower anymore and flush your toilet and, you know, go to the river and grab some water and boil it, right? So day zero is a pretty full-on sort of concept. So this is Guian Wong, and he's part of a group called Stop, Reset, Go. And they decided to do basically a hackathon to crowdsource solutions for water saving from the world. So they worked with a few different partners to essentially curate a knowledge pool to bring those solutions together. And I think they did it at the local science museum or something as one of their partners. And so the exciting thing about this, like they did their hackathon and then it rained and they didn't have a water crisis anymore. So, you know, but the exciting thing is, in the age of climate disruption, many cities around the world are going to be dealing with this kind of stuff. So this means basically what it is a planetary mutualization of knowledge. If Cape Town can do this, then can that knowledge in Cape Town be used for the next town, next city that's suffering from this kind of, you know, from a drought? And then the next, and can we just build from that and that and that and that until we're, as a whole planet, we're building open knowledge to deal with our problems. And that's really what this is all about. How do you take this planetary process of contribution, creativity, problem solving, so we superpower ourselves to solve the challenges that we have in the 21st century. OpenDesk, another example that uses CNC machines. They're, I think, in Denmark, and they have, it's like a two-sided platform, basically. So designers upload their designs, and then you can then say, I want that. But instead of the IKEA model that has to be transported all the way from Sweden or wherever, I tried this. I wanted a quote for a couple of bedside tables, and I got 3 quotes. I was living in Footscray at the time. 3 quotes. One from like Sunshine, the other one from Kensington, and the other one from some other part of Melbourne. Local. They quoted local production of what I wanted, but based on the open design. And open insulin. So this is like, you know, the real social justice side of this. So in the United States, because of process patents, insulin is ridiculously expensive for people with diabetes. And so you got this whole project now in Oakland where they're prototyping insulin production completely outside of big pharma. And And what's really ironic is that the people who invented it, insulin, sold it to the university for $1 because they wanted it to be the legacy of humankind. Right? The irony in that. And here we are again with these, rat bags in Oakland having to prototype their own insulin, right? But it's so exciting because they're already at the prototype stage. They're already testing it. And there's so much regulation. With every single industry you see, every single industry, regulation, right? So they have to deal with regulation here. You can't sell insulin if you're outside of that whole FDA model, but you can use it on yourself. So they can prototype it and use it on themselves. So many here would be familiar with the sort of S-curve or maturity diffusion model. It's very common within sort of diffusion studies and within economics, blah, blah, blah. The basic idea is you have ideation, you got some person with a good idea. Buckminster Fuller says, we should get our energy from the sun, and everyone says you're completely insane, right? But then you have first applications, right? Some people they start studying it in a university, and you got R&D, and then some ideas come up. And then you have sustainability of these things, or the scaling. It begins to scale. Price points begin to shift, right? The way that China got into solar and transformed the price point for solar. And you got replication and fast adoption. Now it's starting to pick up steam, and then maturation and saturation, right? So when we think about these different examples, they're relatively on the early part of this curve, right? So let's not get too excited, right? There's a long way to go. But we see the power of open access, open source in this last wave, right? The last wave was Linux. The last wave was Apache, Wikipedia, right? It hasn't been applied to things, right? We weren't dealing with things, we were dealing with electrons. With electrons, sure, we'll get those across the world really fast. Now we're talking about things. So this is the whole question here. The question is, what does this pathway look like for these different technologies to become mature? And that's a question that, going back to this 3 horizons model, this is a horizon 2 question in terms of Anthony Hodgson and Andrew Curry. Messy, transitional, and that's the entrepreneurial mindset that we have to take forward in order to make this transition. Thank you very much.